What's up YouTube? It's Melton Metal Anthony, and today I'm going to be working on an LM40 trencher, and we just need to do a real simple repair. We need to weld the guard back on. Apparently, this chain has been hitting the guard. Wore it clean off, so we're going to prep this thing out and weld it up. Let me show you what we're dealing with. So as you can see, it wore clean through right there. So what we need to do is prep this thing out. We're going to have to build this back up. And here is the guard. And let me show you how that goes on there. So basically, you just need to weld it back on like so. Just find a way to balance this thing while I tack it. So the challenge of this, probably the hardest part, is going to be to figure a way to balance it. It'd be easy if I had a second person to hold it while I tacked it, but unfortunately I don't. Also, I'm going to need to bevel this thing out the rest of the way because it kind of already beveled itself out. I'm going to need to bevel this half out and this half out so I can get a full penetrating weld. Today I'm going to be welding with a pretty new Miller-Matic 252. This is not my machine. It's the guy I'm working for currently machine. I'm not too familiar with the machine, but I do know this is the on-off switch. Right now it's at 16 volts. I'd say honestly 17 is probably our go-to. And I'm going to go down to 250 inches per minute. And I'm going to see how that treats us. I've already dialed the regulator in back there. The regulator is currently at 15 CFM, which I'm pretty comfortable at on an indoor condition. So basically what we need to do is prep this thing out and see how it goes. All right, as you can see, I prepped it out really well. I prepped this side out really well. And this is 90% of it. You want to keep as consistent of a bevel as you can because it's going to make the welding easier. But because this is so wore through, this is as best as I can do down here. Same thing over here. So we're going to have a little trouble with this. I know that for sure. Now my next step is to try to figure out how to brace this up so that way I can weld it out. So I've got it tack welded, but I can tell it needs to get pushed in just a hair. So the good thing about MIG is it's very flexible, unlike if you were to use 6010 or something along those lines. So it needs to pushed in. This seems about right. It must have been bent at some point. So I'm gonna run this downhill. People frown upon that, but fuck them because they don't know what they're talking about. This is gas shielded. You have no flux to get underneath your puddle. So now that we've got it welded on pretty decently, it's not the best MIG weld in the world, but it'll suffice for holding it on where I need it to. We're gonna turn the volts way up. We're probably gonna go to about 20 volts. We're gonna run it downhill again. I'm gonna see how that runs. I'm gonna move the wire speed up just a little bit, but not too much because my bead is a little fatter than I'd like. Let me show you what that looks like. So as you can see, it's just a little too fat. It's not a bad looking weld. It'll do, but it is just a little too raised for my liking. Whenever you're restarting a weld, you want to nip that little bubble off and get the stick out to be about 1/8 of an inch to 1/4 of an inch. The reason is you'll have less resistance, meaning you'll get a hotter start. I just got to figure out a good position to do this in. It's going to be out of position and it's going to be the wrong angle, but that's just how it is in the repair game sometimes. It's not looking too bad. I'm gonna turn our voltage up just a little bit more. Subscribe! This is a pain in the ass. That doesn't look half bad. Doesn't look great, but for the angle, it looks all right. Really need to get a wire brush in there so I can knock some of that coating that comes off the MIG. I forget what it's called, but I need to get a wire brush. We're gonna kick our wire speed up to 290. I struggled with torch angle during this entire project. This was the biggest pain in the ass of doing this job. All right, guys, I did the best I could with what I had. Unfortunately, because it was such tight quarters, I couldn't really push at the correct angle. So I had to push downhill, had to weld downhill. People frown upon that. But in this application, it's fine. It's not a structural piece, it's just a guard for the blade, so I'm not worried about it. It's definitely not the prettiest bead I ever laid down, but it's the way it goes. Let me show you what I did. All right, I don't know if you can see that. It's not too terrible, it's flat. It's completely filled in. Let me try to get out of the light. But yeah, it's definitely not great by any means. Here's our outside bead again. It ain't going nowhere. That's the main thing. So when it comes to equipment repair, most of the time, it's just make it stick, make it stay, make it work. I'm Melting Metal Anthony. If you enjoyed this little presentation of me welding on this Vermeer trencher, go ahead and like, subscribe, share, do the whole 9 for me. If you didn't like it, well, stick it up your ass.